oh, I forgot one thing. So I already have a snack project for chapter 4 set up. So like we do, we put in the name of the chapter in the README, and then we start programming. So I don't remember what this chapter is about, so we'll see. Okay, so apparently in the last chapters we used some dedicated syntax to lift functions from the pure world into monadic context, yet none of that functionality was higher order, in the sense of assembling large monadic actions out of simpler monadic blocks. Being more concrete, we have functions similar to map or fold, but they use monadic, I don't like to say, that use A to MB instead of plain functions A to B. The answer is affirmative, and the goal of this chapter is to survey those combinators. So if we had a function map +1, 1, 2, 3, right? That would return, let's do this, 1, 2, 3. Sorry, dumb. 2, 3, 4. Right. Now we're gonna take a monadic action. I should probably do this in the REPL, so let's just do that. Right, so map +1, 1, 2, 3, and again, this is perfectly equivalent to fmap, which is also perfectly equivalent to that syntax, right? All of those are exactly the same, so just keep that in mind. You can do a map similar to this. Name print. Why is it in? Oh, hello. I assume Elena is the name of his wife or significant other. Oh, okay, yeah, so that was the point. So you can't do something like this because we're injecting an IO monad here, right? If we just did, we remove this IO monad injection, then this works totally fine, but it's not doing what we want. What we want it to do is print something to the screen. So we need a series of functions that can allow us to do that. Okay. Right, so reminder, type of print is A to IO unit. In this case, A is a string, and therefore we're creating basically this. I'll just, oh, I can't do that. Kind, sure, that will work. Just to print something. I guess I can just, I can't do this. Yeah. So we'll print the kind of it. That's fine. So we have a list of monadic actions, not a monadic action itself. In the later case, the result type would be IO of t for some t. Note the absence of top-level list constructor. There are two approaches to solving this problem. The first one is to write a new version of map that takes monadic action as its first argument. In this way, we arrive at map m. So let's write map m. Oops. How's everybody doing today? Right, so essentially this is going to be Oh no, no, yeah, no, I'm just starting up the stream. Sorry, if that wasn't clear. Yeah, we always start at 7:30, so I put my schedule. I think, do I have a schedule command? Because if I don't, I probably should. Looks like I don't, so I should write a schedule command. We've been pretty consistent with the schedule, so I should probably make it a command at this point. Let me grab a pen. I'll be right back. Oh, you gotta cancel the one. Okay, so. Freeman, I also, is it Freeman or just Freeman? I like to try and be correct when I can. So we need to, doesn't matter? Okay, fair enough. There it is. We'll go with Freeman. So we need to get the result of mapping f with x, and then we need to get the rest of it. Oh, this is clever. I don't think I've ever do this. Freeman. Yeah. No, sorry. I was just emphasizing the pronunciation. Yeah. So we recursively call this on xs, and then well, that's interesting. We should call this something different because it's going to conflict. I think I need to rename it down here. It's not going to work because it's ambiguous, obviously. Okay. Is it, what? How could this possibly be ambiguous? It's not. It's just complaining for no reason. We'll just keep going. Okay, so this is interesting. I don't know that I've ever seen something like this before, even though, I mean, I understand what it's doing. So if we just evaluate f of x, we get our r. This is the part that's new. Oh, that's gonna annoy me. Please, go away. You're fine, I swear. It's gonna drive me nuts, so I gotta fix it. Okay, there we go. Seems fixed. Okay, so anyway. So this has to give me a monad list of B, right? And that's what this piece is doing. So I guess we are recursively calling bind. We're just getting a bunch of R's and then appending them together and then returning the end result. I like it. Okay, cool. I don't know that we've done this before. Not in this style anyway. I think we may have written this in this notation before. I'll show you. Maybe. Hard to say. We want to f map that on. Oh, no. Yeah, so this gives you an IO of R, and then you partially apply this to it, well, it's not IO of R, I'm sorry, M of B, and then you partially apply the cons operator to it, and then you start consing IO of things to it. Okay, cool. I don't know that I've actually written either of these before, so this is actually new. Apparently there's also a 4M, so we can write like so how's everybody else doing today? Pretty quiet in here this far. So gotta get the party started somehow. Where do we get 4M from? Alrighty. Oh, Freeman, since you're here, thank you again, because I'm pretty sure that you've led to 3 follows today. So, already, even before we got on. So that's really appreciated. Definitely look forward to checking out your streams more often. Okay. Then we're gonna rewrite, apparently we're gonna rewrite sequence. But let's call it sequence L because it's specific to lists. So, by the way, these aren't like exercises, they're just showing this code, but I like to try and digest it while I'm doing it. Otherwise, it's, you know, definitely written a sequence function before. Well, I think we can probably write it in a similar way to that. Well, no, probably not. We'll see here in a second. Yeah, no, it's the same thing basically. Oh, I still need the... It's interesting that there's a fold R here. I'm not really sure what this is about. Let's see what it does. Whoa! No, that never seems to do anything. But, I mean, I know that it's just doing this. Okay, so let's dissect this, because this is pretty interesting. So, gosh. So we're going to... What a function. Alright, so this is giving us the... So here, we're gonna write this out again, because I've never seen this reduction before, which means these are definitely sort of new, even though, you know, we've kind of done stuff like this before. So do. So we did this. Okay, and then the above suggests an ancient. That's not. Interesting, H. May. What was the etiquette about? Was it the spreading your legs too wide issue, or uh, that's a party right there. Hopefully it wasn't violent, just a verbal altercation. By the way, I don't think you've after you followed. I don't think you've been back. So just want to say thank you for following because I see you now. Just like reclining, sure. Yeah, that's considered poor etiquette. I ride a bus every day, so I understand that etiquette. The thing that gets me the most is when people don't walk all the way back to the back of the bus and they just stand in the aisles, and you know the bus is getting full and they're not moving. It's very frustrating. Okay, there we go. So now we got some notes in here. So let's do some thinking. So all the pieces are here, right? So here's your empty list case, which is exactly what you need. And then here's your fmap piece. And here's your, apply to everything else. Oh, that's not good. Full on headlock, my goodness. We get some weirdos like late at night. If you're out past like midnight, around 1 a.m. or so on the weekend, things get a little weird on the bus, but I've never seen a full-on headlock fight. That's kind of interesting. It's kind of like put on your headphones and mind your own business and hope for the best. This is pretty wild. I mean, it's pretty readable. Yeah, rush hour. So, very busy. Baby. Baby. You have pad thai? I'm jealous. And a salad for dinner. Eat? No, I don't think it was manspreading. It sounds like it was like, like lounging. Let's see if I can get my feet up. Ugh, I can't. Somebody lounging, getting comfy. Baby! Have you ever seen, have any of you seen Hello from the Magic Tavern? Every time I see something like baby, that's what I think about. So anyway, this function is really cool. I've never seen this before. It seems like a pretty generic thing that one could do. I suppose you need to have an operator that you can stick here, though, right? You don't have this isn't a generic operator. What is semigroup combine operator for lists? It's plus plus, right? Not that. So I don't think there's a generic operator one could put here to make this work in all cases, but it does work for a list. Is this the actual definition of sequence for list? Yes, mapend. But mapend, I think, is plus plus for list, right? We can go look. Google? Mapend? Actually, probably better to look in data list. Yeah, thank you. You beat me to it. But I'm pretty sure that it's plus plus, so that wouldn't work. But if you could have like a generic operator here, then you could have this shape. This is empty in this particular case, but I don't know how you would generalize this. So anyway, let's look at the traverse instantiation for list. This isn't where I find list, is it? How would I find the source code here? So, not bookmark, what the hell? What am I looking for? These are the operations on lists. Where is the actual definition of list? How do I find that? I forget what the definition looks like. My goodness. Here we go. Okay, will this get me there? But those are the operations. This is unfortunate. It would be really nice if I could just get there. Oh, did you see it? And I'm just blind? So do I just search it here? No, not there. I always... I'm not very good at this. Oh, it does? Where'd it go? Data. Doesn't look like it. No, I'm trying to go find the source code for this. Actually, I lied. For that. I'm trying to find instance monoid list A. Maybe I should just write that in Google. That can probably work. Instance monoid list A. Search. Could you be more specific? Because it's in base, right? I mean, it must be. The question is where? Maybe it's in... Is there a data monoid? There is. Let's look in here. Aha! We found it. We did it. Oh, okay. It's just a list comprehension. So it's a little easier. And actually, I'm looking for this. Just this. I guess. Right? Is that what I'm looking for? I think so. I forgot what I was looking for. No, I'm looking for traverse, which is... I'm not looking for that one. I'm looking for traverse. Yeah. Traversable. Typeable. Traversable. Map-M sequence. Reversible. Fold R. Yes. cons f pure. Okay, so this is pretty close actually. This is what I'm looking for. Something like this. Because this is approximately what we're writing. We're just not writing the additional f map, which is why there's this extra lift a2 in here. Right? That's dealing with the f map piece. So right, because a traverse is just an f map plus a sequence. So anyway, what I was trying to figure out is what does this look like for list, and we found it. Does that make sense? What I'm trying to do anyway? I'm trying to see if this is more generic, but I don't think it is. I think that this is kind of specific, but that's okay. All right. Anyway, that was kind of an interesting side note. And apparently you can also, once you have sequence L, you can rewrite sure. I don't love doing this, going down this prime route, but I don't really know what else to do, so we'll just do that. It's like what if we call it like C? I don't know. By the way, C stands for what did C stand for? I had it in my head just a minute ago, like composition or something. Anyway, okay. So that's kind of an interesting side project there. Let's see here. We've sort of messed with this stuff before. We just haven't really used it a lot. So, okay. So now we got a first exercise. Fun. Exercise 4.1. Write for filter. Write implementations for the last two functions introduced above in terms of their pure counterparts, zip with and replicate, composed with sequence. Okay, so of filter M, zip with M, and replicate M using their pure counterparts composed with sequence. Okay. So let's do the other ones first because it says there's something wrong with filter. So we'll see what that is. I have no idea what that is. So zip with M is monad M, A, B, C, list A, list B, monad C. And we need to do replicate M, capital M I wrote. What's up, Edwin's Roar? How's it going? How was your day today? Hopefully you had a less interesting day than, or well, ride home than H may. I'm sure. Oh. MC, right? That would be really important. Man, I'm losing it. Just reading the wrong line. Okay. So we'll write these kind of in the simple way, and do. Day was pretty good. Definitely not that interesting. Sometimes that is totally fine, right? Like non-interesting days are sometimes okay. My day was okay today. I had to write a lot of Python code, so it's not always a great day when I have to write a ton of Python code. I don't hate it, but I kind of really want to write Haskell, but I keep having to like do deadlines, so I can't spend enough time with what I'm trying to do. So I need to do something quick and dirty, and that's my language of choice for quick and dirty, basically. All right, so which one's Python Crash Course? Not sure I know that one. On Crash Course, is it this one? No starch press. No starch. Oh, it's like a book. I see. I see. I can't like look at the first one. I assume I can't look at the first chapter or something. What's the API that doesn't work anymore? Just out of curiosity. All right. So first things first. We got to deal with. Well, oh, interesting. That's unfortunate that it didn't work. Seems like that would have been a poor choice for something that's going to potentially go away at some point. Okay, so I got to use. So it's going to be sequence. I'm sure this is wrong, but let me be wrong for a little bit. What is this? Thought this would be right. Gosh. Font's just a tiny bit too big. Is that okay? You need to see the whole error. Wrong. I need HCID. Readable? Good. Okay. And then I think all I need to do is refresh this side to get colors. Wonderful. All right, so X is an A. Y is a B. So then I should get an M of C. Oh, I need to sequence them at the end. I think that's the trick here. So So that type checks. Right, because I need to give it lists. I can't give it stuff. I can't give it a term A. I need to give it a list. So that would give me we'll fix this in a bit. I'm sure this is not right. Good. Okay. So, right. Remember that this zip with here returns a list of tuples. So it's going to be a list of wait, not tuples. I'm an idiot. I'm sorry. It's going to be a list of MCs. Right? So I want if I sequence that, I'm going to get an M of list C. Actually here, this is what we do. So zip with F X Y is a list. Oh my goodness. List MC, right? So once I sequence that, we end up with this. So what I need to do is combine these. So the way I'd combine this and, you know, another M of C is by first F mapping plus plus over this list of C, and then applying it to the rest of the result. Does that make sense? Something like that. I'm not sure. Is that readable? Does this make sense what I'm trying to write here? I need to combine these two things somehow. And that's how you would do it. Or that's how you get started. Okay. Now. I always love these hints when we're writing these, and then all of a sudden you see down here, use zip with M. Like, yeah, I should use zip with M. I'm trying to write zip with M. Okay, now can we move around some sequencing to make our lives easier? Are there answers in the back of this book? I just thought about that. Have we tried to look at that before? No, there are no answers in the back of this book, so there's probably better ways to write this. But what would they be? That's the question. This makes logical sense to me. I suppose we could make sure it works. That's one thing we could do. I don't know. Anyway, let's move on. So we're gonna take an N and an MA. Um, Wait, why is this type checking? I don't need sequence here. Oh, I'm supposed to use replicate. That's why. Sorry. I'm cheating. Okay, so we need to can't we just write why do I need sequence here? I don't need sequence, do I? I'm a little confused. It does say composed with sequence. But why do I need a sequence here? Do I have the type? It's int MA M list A. Does anyone have any ideas? The key is it says composed with sequence. But it seems to me that I don't need sequence here. But how would I make it use sequence and replicate? Part I'm having trouble with. So, what if we take this and we bind it to I don't see how I get sequence in here. I need a function that embeds structure, but I need to use yeah, because I can't do this. What's the type signature of replicate? Yeah, so if I give it this and then sequence, why is this complaining? I should get a list of MAs. What am I missing here? Oh, I know the issue. The type signature of this is not correct. I need to put like a pure or something here. Right? That's the only way that works. But then this doesn't type check because it's already the right type. Oh, no, it's not. That would be the right type. But because I have to embed some monadic context. So what if I do it a different way? What if we write do a ma let we're kind of doing this probably wrong, but and then we sequence Can't hear me because your sound is off. Alrighty. Thank you for viewing. Oh, wait. He can't hear me. Okay. We typed. Okay. So, yeah. There you go. You need a let. Because the only way you can make this work with replicate and sequence, although, I mean, so this gives me, can we, okay, good. So that's probably a better way to write this. So how do we write this in a slightly better way? It's ma bind sequence replicate and ma. Yep, and we don't need this. Wait. Use but then this doesn't work. I'm very confused. Not quite sure what's going on there. It says to use that, but then it doesn't work. So does this actually do what we think it does? That's the question. And by the way, just for folks who are hopping in, the only reason we're doing it this way is because it says to. So you can write this much easier by just saying, what was it? Replicate n fmap ma, and you're done. So the only reason we're writing it this way is because it says to. What if we put these here? Does the h-lint go away? No, it still says use that, but seems to be complaining. Let's see if this works. Because, like, it might not work. It's not sequence, it's replicate. And we should make sure we use the lib one. 2, and I need a monad of A. Is that what we expect? Yes. Let's use a different monad. How about... No, that's not a... what's a good monad? Yeah, by using pure here, we get the IO monad, right? How do I... Can I just print? What's a type of print? That's IO unit. How do I embed something in IO? I mean, that's pure, but it looks a little funny here. Yeah, there we go. Let's write it more explicitly just so it's clear. Anyway, pure is giving us IO by default. So the IO means print it to the screen, and then we get list 2 right? And we could put it in a different monad, such as list, and you get a list of list, right? We could put it in a different monad. I'm trying to think of another good one that takes something. How about maybe we do that? There you go. So anyway, that's the idea. So it seems to be working anyway. That's really all that matters. What's the other one? Zip with. So we need a function that takes a and a b, and I don't know. We can just write here a, I guess. And then okay, just so it's clear, that's what it's doing. And what we could do is do this just so we get everything, and also we'll add some extra structure just so it's easier to see. Oh, not see, geez. Right, so anyway, there you go. So zip with appears to be working, and replicate appears to be working. What does replicate do if I give it a 0 though? Does it... What about a negative number? Oh, it just treats it as 0. Okay, interesting. Okay, now we gotta figure out filter, but supposedly we can't do it. And also, this is giving me a hint that doesn't work. Oh, that works. Okay. This isn't a redundant bracket, though. You complain when I do this. Oh, no, you don't. I'm just dumb. Ignore me. My bad. So there you go. Sequence. We can write this in a slightly different way if you prefer. That'll... Apparently this doesn't work. I tried to be cute. Okay. Anyway, there we go. Filter. So what do we need to do here? We need to... We need to be able to use filter. How are we going to use filter? We can't extract a function a to bool, right? Is that the problem? Is that right? The only way I can do this, I suppose, is if, excuse me, um, I like apply it recursively, pull out the boolean, check it, and then put it in or out. Cursive definition? Well, we can do this. Let's just write the recursive definition and think about it a little bit. And it adds spaces there, so let's add them. So, right, we need to get the bool from f of x. But we need a sequence in here. Oops. There we go. Let's see if this works, I guess. Alright, so filter M. We're gonna get an A, and let's just say CH May. Take it easy. Hopefully, we'll catch you at another stream. Let's just say just true to save time. We don't need to play around too much. Mm-hmm. Make it a little more interesting. But anyway, it seems to be working as well, so that's good. But you need to be able to call filter with an A to bool, right? So I don't think there's a way to extract this out of there. Is there? Well, let's try and write it up here. So special filter A to M bool. Yeah, so I guess this is the trick, right? You can't extract the bool using any of the normal monad operators that you're familiar with. You need to use some sort of unsafe operation. So I suppose you can do it with unsafe. I don't know, is there an unsafe for a generic monad? Um, uh, this isn't helpful. Is there no unsafe function that does this? Isn't it? I thought it was. Yeah, that's what I'm looking for. Looking for unsafe perform M. Does that exist? If I look for unsafe perform. So that can only do that. You can't do that in some arbitrary one. You can only do that in IO. Okay, that's fine. So anyway, the point is that I was right before, so I don't really need to write that. You can't extract a function a to bool from a to bool from m, a to m bool. Really? The formatter wants that on one line? Okay, that's fine. I think I would prefer if it was like that. I think that's how H format does it. All right, anyway. Nobody's saying anything, so I don't know if that's not, I'm not complaining, I'm just saying. So I don't know if there's something clever that I'm missing in any of these cases, but each of these two cases both say, you know, use replicate M or use zip with M, which makes me think that we're doing okay. And I think this is correct. Like, I think that you first have to get out. Wait. Nope. I think I got an idea. I got an idea, folks. Let's try some stuff. Now I have some motivation because I want to try and make this a little better. That was weird. I must have pressed P. Okay, so all right. So if we zip with F, can you just do this? Yeah. I was way I think I needed to see the sort of the pattern to realize this, but you know, that's okay. Because once I realized, like looking back, that this is just, I'm just embedding this in a list, it made me think like, oh yeah, I did this here, so I can do this here, where I just embed the we just use the list to be our inner monad. Well, it's our outer monad, then we flip it to be our inner monad, right? Anyway, this is a much cleaner, easier version. This is complicated. So after working with replicate M and filter M, it became obvious the above notation is overly complicated. Zip with fxs ys gives me list mc right. So that's it. Pretty easy to deal with. But But I still don't see how we're gonna ever call filter because of this function. Okay, let's keep going. If anyone has any suggestions for this to try, definitely willing to play around a little bit more, because like having this sort of becoming comfy with these things is really important to me. All right, we have a bunch of other functions which I'm not going to. I'm just going to show you in the REPL instead of defining them, because there's no definitions. So probably in Monad. Yep. So if you have, you know, something that's foldable, you can use fold M. So the trick here is that this function embeds structure. Right, so you have a fold M. So this is your accumulator. This is your like value. You need to be able to combine them together to get you the monad of your accumulator. Okay. It says this here. Import control monad extra. Oops. Set package extra. Okay, so this is a partitioning function, and I think what partition does is like, well, we can just try it. I think that if we did partition M, A, if A greater than 2, then just true, else just false, of 1, 2, 3. Oh, yep, I think that's right. So I think what this is going to do is give me a just of a pair that contains 1 and 2 and 3. I'm not sure if they're flipped. I don't know which way they go. Yeah, they're flipped. So you get the everything after and then everything before. It's a little weird that it's flipped, but maybe that's not weird. And what I mean by that is that it's more common that you want this than this. That's kind of what I mean. Although the functor instance would be over the second list. So maybe the idea is you really only want the first list, and then you want to do stuff to it, right? Technically it's a bifunctor, but that's besides the point. Anyway. Concat map. So we could take an A and embed it. No. In a list. What am I doing? And we would just get. Are we going to get list of list 1, 2, 3 or list of list 1, list 2, list 3? Sure. I think we're going to get the first. Oh, sorry, it's a concat map, so that's a bad example. It's just concating these things together. So I'm sorry, you're just flattening. This is any foldable though. I can't think of another example of a foldable. Info foldable. maybe is foldable. So what if we have this on a just so we're embedding the list and combining the maybes, I guess, is what that's doing. It's kind of interesting. And okay, that one makes sense. These ones are kind of like folds. Take while M, drop while M, first M. Okay, I think we get the point. But the interesting point of that is that you get a lot of functionality out of control monad extra, which I've actually never used. Okay, anyway, actions without value. That's the next section. That took us kind of a long time, but I don't know, I think we learned something, so that's important. A pure expression has no side effects, it just computes its output value. In contrast, monadic actions are executed for both their side effects and their result values. In some extreme, but not unusual, cases, a monadic action is apparent only from its side effects. This is the case, for example, when you change the state value combined by the state monad. Or when you print some text to the console. Let me read that carefully. In some extreme cases, a monadic action is apparent only from its side effects. There's a lot of text here, so give me a second. Let me digest this and then just read back what's important. So just give me a second. I think what we're gonna get to is okay, let me just show you an example, and that should clear things up, I suppose. Okay, so the point of all of this is that in some cases, we don't actually care about, is that the right way to say this? We don't actually care about this list of B. So for example, if we're printing something to the screen, right? If we have, let's say, map M, right? So let's say we have this particular case. So map M embeds basically the prints. Really, all we care about in this case is the prints. We don't care about the return value, which is just this piece here. So if we look at the type of this, we'll see that we're going to get a list of unit, IO list of unit, which is like not a useful type. So what you can do is you can throw away this return type by saying, using this underscore. So that way you have a case where you just kind of throw away the result and you're only worried about the effect. So in this case, that's printing A. You could have an effect like reading or writing to a database or something like that. And you know, you don't really care about this result at all. You really just want it to go do the thing in IO and move on with your life. So there's map M and map M underscore and sequence underscore, And what they're doing is they're how do I get void? This is basically what they're doing. They're using this void function composed with whatever function you're interested in, essentially, to take your IO of A and turn it into IO of unit in this particular case. And there's a bunch of these. One advantage of the empty tuple is the ease of constructing one, unit, i.e. If you want to create a monadic action M of unit, you just use return unit, regardless of the monad. In imperative languages, you usually have conditionals where one of the branches may be present. We can provide a similar abstraction for monadic contexts by using the empty tuple as a dummy value. Is this already here? Okay, so what this does is if this is true, it does this. Otherwise, we just return unit. So if bool is false, it's something like if true, then action, where action is f unit in this case, else return right, something like that, but I don't have an action, so anyway. There's also an unless function, which just inverts the action. There's also an if m. There's lots of functions. Lots of functions. Okay, loops. So our walk around monadic libraries now leads us to consider how monadic code interacts with loops. Whereas a while loop does not make much sense in a pure context, since the condition is always going to be the same and thus result in either an infinite loop or one that is never executed, monads are powerful enough to define loops where the condition actually changes in each iteration. Standard library bundled with GHC only defines a single looping function, forever, right? And if you've ever seen forever, just prints things, or well, you can do whatever you want forever. Right, so forever, just two, I think. Well, this won't actually do anything because I need to like actually do something. There we go. We do forever print 2, for example. We just run print 2 and then do that again and again and again and again. If I just have a just there, it doesn't do anything. Can't do that. Let's see here. There is a while m loop. Are these all in monad loops? It might be easier to just go look at their source code. Where did... Okay. Oh, it's right there. Well, this looks very different than what it looks like in the book, but this one is just using... I think it uses this monad plus function. Yeah, that's where this m plus comes from. Yeah, so monad plus I think defines m plus and m0, which is what they're using to make this happen. So it's a little different than in the book, but gives you an idea of what's going on. There's an iterate function. There's an iterate until m function. And there's the loop m function. I don't think I've ever used loops in Haskell, other than I've used forever, I suppose. I've used forever. Let's keep going because I don't know when we're gonna use loops anytime soon. Okay, so traversable. The list constructor supports two ways of mapping a function over all of its elements. I need to get water. Hang on, water run. Okay. It's very hot in my house. Okay. The list constructor supports two ways of mapping a function over all its elements. Map or map m. In section 1.5, we discussed how the first notion could be extended to other type constructors, giving rise to the functor type class. Can we do the same for map m? The answer is affirmative, and we will see in this section the corresponding notion is traversable. Okay. So, let's use... What do we want to use? Okay, so this is going over some shape stuff, but anyway, the point is that it leads to the following: info reversible. I did not realize that map m was an option in traversable, but why? We need to define traverse or sequence A, so it just derives map m for us. Why is that shown in here? Okay, so traverse, this function is exactly the same as map m, but it asks for an applicative functor instead of a full monad. Oh, I see. I didn't see that. So that asks for applicative functor. This asks for full monad. Shape is exactly the same. TA, TA, MTB, FTB. Perfect. Okay. And there's, again, sequence A and sequence are the same functions. One's applicative, one's in the monadic context. Wonderful.